A very good morning to both my respected panels and my fellow friends. So today I'm going to do my FYP presentation. First of all, let me introduce myself. My name is Yap Zhi Xuan and I am from Year 2 DEK Section 1. The title for my FYP project is Improvement on Food Waste Composer. The supervisor for my project is Puan Ainai Nor Binti Hanafi. So let us first have a look at the title of my project, Improvement on Food Waste Composer. I'm sure everyone here knows what's the meaning of a food waste, but what's a composer? Composer actually comes from the word composting. Composting actually means a process of recycling, or in other words, converting organic materials like dried leaves or grass into fertilizers for plants. So basically, a food waste composer is a machine which converts food waste into fertilizers which can be used for plants to promote plant growth. Okay. Next, I'm sure some of you may be wondering why improvement on food waste composer. So basically, the project of developing a food waste composer actually comes from a group of BEK students from degree. So they actually used this title for their capstone project last year, and I am extremely honored because I am given this opportunity by my supervisor Puan Ainai to make a few improvements on this existing food waste composer. So throughout my final year project, I have managed to reconstruct the circuit of the food waste composer, and I have made a few improvements on that food waste composer so that it becomes more productive and also efficient. So yeah, before I start my presentation, unfortunately due to the ongoing pandemic, the experiment on the real hardware could not be carried out. Therefore, I'm going to carry out the demonstration for my project through Proteus 8 Professional. So yeah, let's proceed with my presentation. Problem statement. Over the years, increment of human population has led to increase in the amount of waste produced. Most of the time, food waste was sent to landfill, and this has caused the overflowing of landfill. This has become a major issue due to the greenhouse effect produced by the food waste itself. Due to this issue, home recycling has been one of the alternatives used in order to reduce food waste. However, the time taken for traditional food decomposition process is just way too long. So, how do we tackle this problem? Fear not, this is the reason why an indoor food waste decomposer has been made. An automatic food waste decomposer shortens the time required for decomposition of food waste by carrying out dehydration and also grinding. The decomposed food waste can be used as fertilizer for plants, which promotes plant growth. Next, a few improvements has been made on the existing food waste decomposer. First, the addition of saw blade as the grinder of the food waste decomposer. Next, replacing hairdryer with industrial heater, and thirdly, changing the orientation of the grinder. Now, let's have a look at the objectives of this project. First is to improve the functionality of an existing food waste decomposer and make it more productive. Secondly, to convert food waste into fertilizers that can be used for plants. Last and not least, to reduce the time taken for traditional decomposition process. Methodology. Due to the ongoing pandemic, experiment on the real hardware could not be carried out. Therefore, there are a few changes that has been made from the originally planned methodology. The methodology of this project has been divided into 4 stages. The first stage, conceptual design. During this stage, I have came up with ideas on how to improve the existing food waste decomposer. I have also briefly sketched the design of the prototype on my logbook. Next, programming simulation. During this stage, I have constructed a flowchart based on how I want the machine works. Next, programming of the machine has also been written at Arduino. After that, the simulation of the circuit has also been carried out at Proteus. Thirdly, prototype sketching. Since the experiment on the real hardware could not be carried out, I have sketched the design of the prototype at AutoCAD. The last stage, analysis on circuit. During this stage, I have came up with ideas on how to make the prototype more user-friendly, and I have made sure that the simulation works exactly as planned. Now, I'm going to talk about the inputs used in the food waste decomposer. Start button is the first input used. The user can press it if she or she wants to start the machine. Next, a stop button. It is pressed whenever the user wants to stop the machine from its operation. Thirdly, an infrared sensor. An infrared sensor is used to measure the level of food waste inside the food tank. Lastly, temperature and humidity sensor. It is used to ensure that the temperature and humidity inside the food tank is within the prescribed level. Next, the controller. Arduino Uno is used as the main controller of the food waste decomposer. Outputs. The indoor food waste decomposer has three outputs. The first output is LED, which acts as the indicator for the machine. A total of 4 LEDs were used. The yellow LED is on whenever the machine is ready to function, while the blue LED is on when the machine is under operation. Next, the red LED. The red LED is on whenever the infrared sensor signals that the food waste inside the food tank is full. Last and not least, the green LED is on whenever the food decomposition process has been completed. Industrial heater. It dehydrates the food waste inside the food waste decomposer and makes sure that the temperature and humidity inside the food tank is within the optimum level. The next output is a 24-volt DC motor. It moves the grinder so that the food waste will be grinded into small granule pieces. AutoCAD sketch. Due to the ongoing pandemic, experiment on the real hardware could not be carried out. Therefore, the design of the indoor food waste decomposer has been drawn using AutoCAD. First, we're going to have a look at the control panel of the food waste decomposer. It has 4 LEDs and 2 push buttons. The green button is the start button for the indoor food waste decomposer, while the red button is the stop button for the food waste decomposer. Next, shaft with saw blade. The shaft has a 2 cm diameter and is 35 cm long. This will be the grinder of the machine, which will grind the food waste into small granule pieces. Saw blades will be connected to the shaft using a hot glue gun. Thirdly, the DC motor. The DC motor will be connected to the shaft and act as the prime mover for the grinder module. Next, the main storage. The main storage has a height of 70 cm and a 30 cm diameter. It is the place where the food waste are stored. Besides that, both the infrared sensor and also the temperature and humidity sensors are placed inside the main storage. Fifth, industrial heater. It has a 20 cm diameter with a 24.5 cm height. It dehydrates the food waste inside the food tank. Lastly, we are going to have a look at the overall design of the indoor food waste decomposer after integrating all the modules together. The indoor food waste decomposer have a total height of 86 cm with a 45.75 cm width. This is the control module of the food waste decomposer, DC motor which will be integrated with the shaft inside the food tank, and industrial heater which is also the heater for the machine. First, limitations. Due to the ongoing pandemic, the real hardware couldn't be experimented. Therefore, there are a few limitations when it comes to this project. The effectiveness of the prototype could not be tested out. Since we are doing this project using simulation, the suitability of the saw blade cannot be tested out. It is important to make sure that the saw blade is sharp enough to cut a wide range of food. Next, DC motor speed. In the real hardware, the speed of the DC motor can be controlled by a DC motor controller, as different kinds of food waste require different speed to cut them into small pieces. Therefore, a variation of speed is restricted. The second limitation is the replacement of sensors with push button. The sensitivity and the range of both sensors used could not be tested out since they have now only have on and off conditions during the simulations. Both the sensors play an important role in making sure that the condition inside it is within the prescribed level. The third limitation is the restriction when it comes to selection of material during construction. It is important to make sure that the machine is constructed with materials that are waterproof and corrosion resistant, since the machine often dealing with food waste that are wet and humid. Improvement on prototype. Since one of the objectives of this project is to make improvement on an existing food waste decomposer, therefore, a few improvements has been made in order to make the indoor food waste decomposer much more efficient. The first improvement that have been made on the prototype is the replacement of fan blades with saw blades. The reason behind this replacement is because fan blades are not sharp enough to cut bones and meats, while the saw blades are much sharper and efficient when it comes to grinding food waste into small pieces. The next improvement that have been made is the replacement of hairdryer with industrial heater. The reason behind this replacement is because the heating process is less efficient with hairdryer due to the size of its nozzle. The industrial heater, which have a higher rated power, makes the heating process much more rapid and efficient. Third, the addition of green LED. Why do I do so? This is to ensure the safety of the user, since the green LED will only light up when the food decomposition process has been completed. This will make the user much more alert by making sure that the food tank is properly closed whenever the green LED is off. The last improvement that we've made on the machine is the change in the orientation of the shaft. The shaft is changed to a lower position. This makes sure that the food waste will be grinded into small granular pieces, regardless of the height of the food waste. In general, all the objectives of this project has been achieved. The first objective is to improve the functionality of the existing food waste decomposer. This objective has been achieved by the addition of saw blade, green LED, and also the industrial heater. The second objective that has been achieved is to convert food waste into fertilizer for plants. After undergoing the food decomposition process, the food waste can now be used as fertilizers, which promotes plant growth. The third objective that have been achieved is reducing the time taken for decomposition process when compared to traditional method. With the addition of industrial heater and also the grinding module, the decomposition process has become much more faster and efficient when it is compared to the traditional method. After completing the project, a few suggestions have been made in order to improve its overall performance. First is the addition of IoT. With the addition of IoT, the user will be able to control the machine even though they are not at home, as long as they have Wi-Fi connection with them. The next suggestion that have been made is the addition of gas extraction unit. It will be able to tackle odor and bacterial problems, which might cause air pollution. So in general, that is it for my presentation. It is undeniable that there is some limitations when it comes to my project since the experiment on the real hardware could not be carried out. However, I hope that my project will be able to play a small part in reducing the amount of food waste and also promoting plant growth so that together we will be able to make this earth a better place for us to live. Thank you.